Use the sum and difference identities to find the exact value of the following. Cosine of 5 pi over 12. So for this problem, I'm going to use the sum identity of cosine, which states that cosine of alpha plus beta equals cosine alpha times cosine beta minus sine alpha times sine beta. So you have to find two angles that add to equal this angle. So there's two ways to do this. You can guess and check by using the unit circle, or you can convert this, which is currently in radians, to degrees and find two angles that add up to equal what that equals in degrees. So I found that the two angles pi over 6 and pi over 4 have a sum that equals to 5 pi over 12. How do I know that? Because when I tried to get these two common denominators to add these, I multiplied this side by 4 and I multiplied this side by 6 to get 4 pi over 24 plus 6 pi over 24 equals 10 pi over 12, or 24, sorry, which simplifies to 5 pi over 12, which is that. Another way you can check is you can convert this to degrees and get 75 degrees, and these two are 30 degrees and 45 degrees. So you know that 30 plus 45 equals 75. So that's another way you can check. But these are our two angles that I am going to call alpha and beta. So I'm going to use this formula. Cosine of alpha plus beta equals cosine of pi over 6 plus pi over 4 equals cosine of pi over 6 times cosine of pi over 4 minus sine of pi over 6 times sine pi over 4. So we're going to find these values using the unit circle. The cosine of pi over 6 is radical 3 over 2 times the cosine of pi over 4, which is radical 2 over 2. And we're going to subtract that from the sine of pi over 6, which is 1/2, times the sine of pi over 4, which is radical 2 over 2. Multiplying these, you get radical 6 over 4 minus radical 2 over 4. And you can combine these because they have like denominators and state your final answer as radical 6 over radical 2, radical 6 minus radical 2 all over 4. This is how you write the cosine of 5 pi over 12 in exact form.